over graphing the factored form of a quadratic. Okay, so in our last lesson we went over graphing translations, and that was specifically in vertex form. In vertex form, it's quite easy to graph this. We know the vertex being our h and k value, and then we kind of just draw the parabola from there. Standard form we've done absolutely no graphing with, and really the only information for a graph we can pull from it is this c. C is the y-intercept in standard form, okay? So y-intercept, write that in, c equals the y-intercept of that graph when we're in that form, okay? And what we're really going to focus on today is factored form. Now the two that we use for graphing are vertex and factored form. We're going to talk about how to go from standard to factored form, and then how to graph from factored form. Okay? So, what we have here is we have our two sets of brackets, and we have A being the same term in all three forms, and R and S are our X-intercepts. Okay? So we'll write that down. R and S equal X-intercepts, for the most part. Things can change, but that's the idea, intercepts. It depends if there's a value in front of x. If there's a value in front of x, then it's not technically R and S, but we'll get to that. So factored form, we're going to go through our first example when it's in factored form. Okay. So our very first example says y is equal to 2, plus 1, and x minus 7. Okay. I'm going to show you the proper way to find the x-intercepts, just because that will help when we go farther into the next chapter, and we learn how to properly do it right now. So, first thing I need you to recognize, what form are we in? Are we in standard form, vertex form, or factored form for this equation? Factored. Okay, very important that you can recognize which of the forms we're in. Okay, we're in factored form. What would be considered my A? 2. That's right. And what are the R and S? Okay, and they're also the numbers positive 1 and negative 7. Okay, now an x-intercept on a graph, make a makeshift graph here. We have our parabola. Our x-intercept is when the y value is equal to what? Anyone know? 0. That's very important. So an x-intercept is when y is equal to 0. So in order to solve that in the question, what we actually do is we set y equal to 0. So we get 0 is equal to 2. X plus 1, x minus 7. Okay? And the goal is to solve for our x variables. Well, first thing we want to do is reverse bedmass, so we're going to deal with the multiplication first. If I were to divide both sides by 2, what is 0 divided by 2? 0. That's going to change. And here the 2's would what? Anyone know? When I divide this by 2, what these 2's do to each other? They essentially cancel out. They create a 1, but you could say they cancel out. So then all we're left with is x plus 1, x minus 7. Now, the idea here is that these are two terms, this being one and this being the other, multiplied together that equals 0. Okay? What number can we multiply by to get 0? 0. It's the only term. Okay? So what we're going to do is we're going to solve as if both terms were 0. So we will split this question. We're going to set both brackets equal to 0. 0 is equal to x plus 1, and 0 is equal to x minus 7. Okay. That way we're solving for what both these brackets would be 0. So in the first case, what would x be in this? When I bring the 1 over, it becomes negative 1. So x is negative 1. Or the other option is when we bring that negative 7 over, x equals positive 7. Okay? Now, I want to draw your attention to the R and the S. Okay? If you noticed, our R and S were positive and negative 7. Well, our x-intercepts were just the opposite operation of those terms, negative 1 and positive 7. Okay? So you can easily recognize that. I just wanted to show you the proper mathematical way of doing this, because when we get into chapter 6, you're going to have to know this. If there was a value here, it's very important to do this process. If there's only a value of 1 in front of both x's, then you can look at these and just choose the opposite operation. Okay, so keep that in mind. This is a shortcut. You can look and see if the coefficients in front of the x's are both 1. And today, I think for most of what we're going to be doing, all of the x values will have a coefficient of 1, it looks like. Yeah, so, all right, so that'll be the quick way to look at it will be, this would be positive 7, this would be negative 7. Just the opposite of what the r and the s are. Okay? So now that we have that information, we can graph some x-intercepts. Put a graph up here. So, our x-intercepts in this case. One of them being positive 7, so that means we cross the x-axis at 7. And then one of the other ones, we cross the x-intercept at negative 1. Okay? So those are two major points for us. We've got that information. The vertex is going to fall in the middle of those two. Okay? Because our parabolas are always symmetrical, whether it's being drawn this way or this way, we know the x value of the vertex, or known as the axis of symmetry, will be right in between those two. Okay? So our AOS, or axis of symmetry, is equal to r plus s divided by 2. In other words, the two x-intercepts, which are r and s in this case, negative 1 and 7, and divide them by 2. That's how we find halfway between them. So our x-intercepts in this case are negative 1 and positive 7 divided by 2. What is negative 1 and 7? What's 6 divided by 2? 3. So the axis of symmetry and the x value of the vertex, axis of symmetry is that imaginary line cutting through the middle of the parabola, is right here at 3. So we know the middle of the parabola is there. What we now have to figure out is the y value of the vertex. Does it go like this? Does it go like this? Is it down here and it's opening up? That's the only step left, finding the y value. So in terms of the vertex, we have the x value. The x value of the vertex is 3. We now sub 3 in to the original equation to find y. So that original equation is way up here. Okay? We're going to sub the number 3 in for these two x values. Okay? Because we know the x value of the vertex is 3. So we're going to sub it into this equation to find and solve for y. Let's rewrite it. Y is equal to 2, x plus 1, x minus 7. Well, we know that the x value of the vertex is when x is equal to 3. So we're going to replace both the x's in those brackets with the number 3, and we're going to solve for y. Y is equal to 2, 3 plus 1, 3 minus 7. Okay? We just replaced both x's with the value of 3. So, we solve brackets first. What's 3 plus 1?
4.
And what's 3 minus 7? Negative 4. Good. 2 times 4? Times negative 4?
Negative 32.
There you go. Negative 32. Okay? Well, in this one, what it ends up being is a number that's not really on our graph. Our grid only goes down to 10. Let's say this was going by 10s instead of 1s. Okay? Are you guys able to comprehend that? Okay. If it was going by 1s, our y value of our vertex would be way, way down here. Okay? So we'd have some parabola that reached all the way down here. But since we want to try to show it on a graph, we're going to estimate where 32 would be. It'd be about there. Okay? Remember, it completely depends what your graph is going up and down by. So we're going to say that this one's going up and down by 10s. Your y and x value can change by different amounts. So here's about 32. So in other words, our graph of our parabola looks something like that. Okay? There's our parabola. We use the x-intercepts to figure out where the vertex was. Okay? We use those 2 points to find out the vertex. Those 2 points were the r and s, which were positive 7 and negative 1. And our vertex was at 3 and negative 32. Okay? Negative 32. A lot of steps there. Remember, we don't always have to do this middle part. As long as we recognize that the x value in front is a 1, we can instantly know the x-intercepts as being -1 and +7. And from there, we find the axis of symmetry and then the y value of the vertex. Okay?